Today is the final meeting of the project. Today is also the demonstration day to the funder and consortium stakeholders. We have finally come to a point now where we can successfully demonstrate and effectively show what we've done in a nicely integrated manner.
And it's actually been a really great experience to work with people in academia, see how they approach things differently. We've all learned a huge amount. Even with all the challenges of COVID, that kind of got thrown in at us just after the start of the project.
So for the last 2 years, we've not been able to meet. A lot of the progress has been hindered by that fact. Each of the collaborators had different disciplines and not necessarily understand what the other ones are doing. So that would have been easier to explain in front of a whiteboard, but more difficult to do in a Zoom or a Teams session.
Organizational-wise, it opened a very huge opportunity for the Coventry University in order to get connected to the industry to provide security for the future CAVs.
If you look at the cybersecurity landscape, it's all about vulnerabilities, threat surfaces, threat attempts, and so on. So in that respect, this project has been pretty important in terms of opening up, if you like, opportunities to safeguard systems by design, in a way.
Up to now, every solution that provided commercially was software-based. And this was the first hardware-based monitoring solution for the automotive, which actually triggered a new way of thinking to manufacture automotive system and subsystem in a more secure way.
Innovate UK is all about multiple entities collaborating together. Each party brought different sets of skills. We had Copper Horse, who their specialism is in security and threat modelling. We had Coventry, who are the Centre of Excellence for Automotive Research and Design in the UK. And then we had Southampton, who were looking at some forward-leaning ML techniques. And then we had Siemens, who provided silicon IP and the analytics.
Security and safety are fundamental now, not just to our digital safety and digital well-being, but also potentially in the case of automotive, it could be a matter of life and death. We can show that there are technologies there that could, in real time, detect potentially life-threatening threats. So that's a big achievement, I think.
Cyber-physical systems will get more and more complicated. So it's all about complexity and how you handle complexity. And it's not about ensuring particular components are secure. It's all about the system.
But it's also about how those concepts of this project have a applicability in other areas as well. So they are not, if you like, isolated to the automotive space. They could be extended to, for example, the health sector, or indeed other elements where security is of the essence. It all boils down to trust, if you like, because we have technology and we have very advanced technology. The question is who's going to use it and why they want to use it. At the moment, technology needs to do a lot more to instill that trust to the public audience.
The sector is still new. A lot of the concepts and technologies are still emerging. For us to have a deep tech analytics platform like this deliver on actual abuse cases and to show that we can detect them in a timely manner, in an effective manner, is a remarkable step.
This project has really given us the opportunity to pull our IP into a complete system. We're now in a position where we have a really neat platform and setup, so anybody can come to us with a particular abuse case they want to look at, and very quickly we can implement that and show the best way to approach mitigation and identifying that challenge. We managed to achieve everything we set out to do, but it's a huge area and there's lots more research and a lot more work to be done.